Namaste children. I hope everyone is safe in the home. Be safe, stay home. Take necessary precautions to eradicate or to cure this coronavirus. Don't come out of your home and listen to your parents' words. Thank you. Right. In the last class we will discuss this squares or perfect square numbers and their properties. Today in this class we will discuss some interesting patterns where we will find the square numbers in the interesting patterns. So our topic it is some interesting patterns. In lower classes also you might have come across numbers and their patterns. Rangolis, although Rangoli you might have come across these patterns in Rangoli given in the symmetry. Now we are going to discuss about the square numbers in the form of interesting patterns. So here, that the first one it is adding triangular numbers. Adding triangular numbers. What are triangular numbers? What are triangular numbers? See the word triangular means triangle. Triangle means a geometric figure with three sides. A closed figure with three sides is known as a triangle. Now here triangular numbers means the numbers whose dot patterns can be represented in the form of a triangle. It is possible for other than this one it is possible. For example, you take this three dots is there. So if you join these three dots, you will get a triangle. You get a triangle. Similarly, if you join this six dots, you will get a triangle. You get a triangle. And then 10 dots are there. These 10 dots, if you join, you will get what? A triangular form. A triangular shape will get. So next is 15 dots. If you take, you will get a triangular form. These kind of numbers are known as triangular numbers. So what are triangular numbers? The numbers whose patterns can be written in the form of a triangle are called triangular numbers. Now, why do we study here these triangular numbers under squares? See here, if you add two consecutive triangular numbers or two successive triangular numbers, for example, 1 plus 3, 1 plus 3, what we get it is 4. 4 is a perfect square number. 4 is a perfect square number. See here, if you join this 1, 2, 3. So this is 3 dots, number 3 it represents 3 dots. Then if you keep here one more dot, then it will represent completely what? This 1. This 1 represents 1 dot and these 3 dots represents number 3. When you add this, you get a square shaped form. Square form. That's why by adding two consecutive triangular numbers, we will get a perfect square number. For example, 1 plus 3 is equals to 4. Similarly, 3 plus 6, 3 plus 6, that is equals to 9. 9 is a perfect square. 9 is a perfect square number. And next, if you go for these two numbers, 6 and 10, 6 plus 10 is equals to 16. 16 is a perfect square number. That is 4 square. 4 into 4 it is 16. Then even if you go for the next triangular number, it is 15 is the next triangular number. By adding this 15 to this 10, we get what? 25. This 25 is also a perfect square number. Children, can you guess what will be the next triangular number after 15? Yes, it is 21. It is 21. So if you add 21 to this 15, 21 to this 15, what we get it is 36. Thus 36 is also a perfect square number. So we find these patterns numbers as squares, perfect squares like 4, 9, 16, 25, 36, 49 and so on. So this is one interesting pattern where we will find the square numbers in this pattern. I hope you understand this pattern. Next we will go for the second pattern, it is numbers between square numbers, perfect square numbers. How many numbers are there which are non-perfect square? Non-perfect squares between two consecutive square numbers. Two consecutive square numbers. How many numbers are there? We will see here. What are the first two perfect square numbers? 1 is a perfect square number, that is 1 square, and 2 square is equals to 4. 4 is a perfect non-perfect square number. Between 1 and 4. Between 1 and 4. How many numbers are there which are non-perfect squares? What are the numbers are there? Which natural numbers are there between 1 and 4? 2 and 3. How many numbers are there? 2 numbers are there. Are they perfect square numbers? No. They are non-perfect square numbers. They are non-perfect square numbers. Next, we'll see one more pattern. We'll see one more. The next two consecutive perfect square numbers are. You see here. 2 square is equals to 4 and 3 square is equals to 9. Between 4 and 9, how many non-perfect squares are there? We will see. What are those numbers between 4 and 9? 5 is one number, 6 is one number, 7 is one number, 8 is one number. So here, how many non-perfect squares are there between 2 square and 3 square? That is 4 and 9. 5, 6, 7, 8. Total 4 non-perfect squares are there. Square numbers are there. And here 2 non-perfect squares numbers are there. We will go for one more example. Next we take 2 more. It is 4 square is equals to 16. 5 square is equals to 25. So between 16 and 25, both 16 and 25 are perfect square numbers, are simply square numbers. In between these two numbers, which numbers are there? Let me write 17, 18, 19, 20, 21, 22, 23 and 24. Now how many numbers are there here? 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers are there which are non-perfect square numbers between 4 square and 5 square. Between 4 square and 5 square, that is 16 and 25. How many are there here? It is 8 numbers are there. And here how many numbers are there? 4 numbers are there. Here how many numbers are there? 2 numbers are there. Where between 1 and 4 we have 2 non-perfect squares are there. That is 2 and 3. 2 numbers are there. And between 4 and 9, which are 2 perfect squares, between these 2 numbers we have 5, 6, 7 and 8. 4 non-perfect square numbers are there. Similarly, 16 is a perfect square number and 25 is a perfect square number. See that both the perfect square numbers should be consecutive number. Consecutive square numbers means one after the immediate next square number, that is successive number. Successive square number. So between 16 and 25, which numbers we have? 17, 18, 19, 20, 21, 22, 23, 24. Total how many numbers are there? 8. Total how many numbers are there? 8. Similarly, if you go on like this, we'll come to know one number is there, n square. The other number is n plus 1 whole square. N plus 1 whole square. Then how many perfect square numbers are there between these two numbers? We'll conclude by using these 3 patterns. See here, how many perfect square numbers, non-perfect square numbers are there? Here it is 2 non-perfect square numbers are there. That is 2 comma 3. It is 2. Here, observe here. What is the first square number? Here it is 1 square. It is first natural number. It is 1. So 1 into 2, it is 2, or 2 into 1, it is 2. Similarly here, 2 square, and it is 3 square. 2 is the first natural number, 2's square number is 4. So 2 into 2, 4. This is 1 into 2, and it is 2 into 2. What this 2 represents? What this 2 represents? The first natural number among between the both perfect square numbers. See, the 1 represents what? The first natural number between these 2 natural numbers. Then if you come here, 4 square and 5 square, 4 is the first number and 5 is the next immediate number. How many non-perfect squares are there here? 8. 8 means it is 4 into 2 we can write here. 4 into 2 or 2 into 4 we can write here. So 2 into 4 or 4 into 2 we can write here. If you observe here, what it is? 2 into 1. If you observe here, the first digit represents what? 2 is the common among all the patterns. 2 is the common among all the patterns. Then what the second number represents? 1, 2, and this 4 represents. 1 is the first number in these 2 numbers, and 2 is the first number in these 2 numbers. 4 is the first number in between in these two numbers, 4 square and 5 square. So from this what we can conclude, how many non-square numbers are there between two consecutive square numbers? It is double the number, double the first natural number for which we have chosen the square. Let the first natural number is n, and the successive natural number is n plus 1. N square, its square is n square, and n plus 1 square will be n plus 1 whole square. Between these two, how many non-perfect square numbers are there? Double the or twice the, 2 times the n, 2 times the n. Why it is 2 times the n? If you observe here, 4 represents what? The first number in these two numbers, 4 square and 5 square. Here 2 represents, 2 is the first number, and 1 represents this 1 square means it is the first number here. So in n square, that is n and n plus 1, these two are two successive natural numbers whose squares are n square and n plus 1 whole square. So how many non-perfect square numbers are there between n and n plus 1? It is 2n, twice the number of n value. If n is equals to 2, we will get 2 into 2, 4. If n is equals to 3, we will get 2 into 4, it is 8. If n is equals to 5, how many will get? 2 into 5 is 10. Now, I hope you understand this. Now, I will ask you a question. How many non-perfect squares are there between 5, square of 5 and square of 6? That is 5 square and 6 square, which is equals to 25 and 36. How many non-perfect squares are there between 25 and 36? How many are there? 25 can be written as what? 5 square, and 36 can be written as what? 6 square. In these two, which is the first number? This is smallest number, smaller number, 5. So how many non-perfect square numbers will be there between 25 and 36? It is 2 into 5, that is 10. 10 non-perfect square numbers are there between 25 and 36. Even if you go for the other numbers, 100 is a perfect square number. 100 is a perfect square number. Now, the number of non-perfect squares between 100 and 121. 100 and 121. 100 means it is 10 square, and 121 means it is 11 square. How many numbers are there between these 100 and 121? We have 20 numbers are there. What are the 20 numbers? 101, 102, 103, 104, and so on, 120. 120. How many numbers are there total? How many? 20 numbers are there. What kind of numbers these 20 numbers? These 20 numbers are non-perfect squares. So they are between 100 and 121. So without writing these numbers, we can easily say how many non-perfect square numbers are there between two consecutive perfect square numbers, that is natural numbers. So here 10 is the smallest number, 10 and 11, 10 is the smaller. So 10 into 2 times of the smaller number, it is 20. Hence 20 numbers are there. Similarly, let n and n plus 1 are two natural numbers and their squares are n square, n plus 1 whole square. Between these two perfect squares, how many non-perfect squares are there? Means twice the number of n, that is 2n. Twice the number of n. It is n square and n plus 1 whole square. How many numbers are there between these two? 2n non-perfect square numbers are there. So this is one thing which we need to learn here in this interesting patterns. Now we will discuss one more pattern. It is we can write these perfect square numbers as the sum of two consecutive numbers. Two consecutive natural numbers. Perfect square numbers. Some perfect square numbers we can express them as sum of two consecutive numbers. For example, take 9. 9 is a perfect square. 9 can be expressed as 4 plus 5. 4 and 5 both are two consecutive natural numbers. Similarly, next 25. 25 can be written as 12 plus 13. 12 plus 13. 12 and 13 are two consecutive numbers. Then 49 is there. 49 we can write it as what? Two consecutive numbers as 24 plus 25. 24 plus 25. And 81 is there. 81 can be written as 40 plus 41. Like this, perfect square numbers can be expressed as sum of two consecutive natural numbers. Sum of two consecutive natural numbers. Then, even if you go for one more example, what it is all, then if you want to write 121 is there. 121 can be written as 60 plus 61. And like this we can write. So if you observe here 9, 25, 49, 81, 121, what are all these? Odd perfect square numbers, odd numbers. So odd perfect square numbers can be written as sum of two consecutive numbers. What about even perfect square numbers? Even perfect square numbers, if you take 4 is an even perfect square number. 4 can be written as 2 plus 2, no consecutive numbers. Even if you go for 36 is there. 36 can be written as what? 17 plus 19, but they are not consecutive numbers. They are not consecutive numbers. So from this what we can conclude, this odd numbers except one odd perfect square numbers can be written as sum of two consecutive numbers. Then next one, it is adding odd numbers from 1. What we get to the other part. The third one, it is adding odd numbers. Adding odd numbers. What we get by adding these odd numbers, we will see. Except 1. 1 is an odd number. 1 is an odd number. Except 1. The other odd numbers, if we add this consecutive odd numbers, we get what we get? 1 plus 3. Both are odd numbers. 1 plus 3 is equals to 4. 4 can be written as 2 square. How many odd numbers we are adding here? It is 2 consecutive odd numbers. By adding 1 and 3, what we got? 4. That is 4 can be written as 2 square. 4 is a perfect square. Similarly, 1 plus 3 plus 5 is equals to 1 plus 3, 4, 4 plus 5, 9. 9 can be written as 3 square. 9 can be written as 3 square. What about 9? 9 is a perfect square number or not? That is 3 square. How many odd numbers we have added here? It is 3 odd numbers. And what this 3 represents? This 3 represents the number of consecutive odd numbers. Here the 2 represents number of consecutive odd numbers which are added. Next we go for one more. 1 plus 3 plus 5 plus 7. That is 1 plus 3. 4, 4 plus 5, 9, 9 plus 7, 16. 16 is equals to 4 square. That is 4 odd numbers are added and we got that sum is a perfect square, which is 16. Odd numbers should be started from 1. We should add from 1. Next it is 1 plus 3 plus 5 plus 7 plus 9 is equals to 25. 25 it is 5 square. 25 it is 5 square. How many odd numbers we added here? 5 odd numbers, and whose square it is 25. We got by adding first 5 odd numbers is equals to 25, which is a perfect square. So from this what we can conclude, by adding odd numbers from 1 we will get the perfect square numbers. How many odd numbers we add, that number square we will get by adding. And if you add n numbers, 1 plus 3 plus 5 plus 7 plus 9 plus and so on n. So what we get? N square. What we get? N square. So from this what we can conclude, by adding successive odd numbers from 1 to n we get n square. What we get, it is n square. So easily what we can say, sum of first n odd numbers is equals to n square. Sum of first 5 odd numbers is equals to 5 square. Sum of first 10 odd numbers is equals to 10 square, that is 100. Like this we can conclude here. Then what we can say, what about these other numbers which cannot be added or which cannot be written in this form? You will see here. Take any other number, for example, 32 if you take, 32 is there. 32 can be written as the sum of odd numbers. No, we cannot write this as the sum of odd numbers. For example, we take 1 plus 3 plus 5 plus 7 plus what it is 9 plus 11, 20, 32 and 36. 36 we get, but we won't get it is 32. So 32 cannot be written as sum of odd number, consecutive odd numbers. From this, what we can say that only perfect square numbers can be written as sum of consecutive. I hope you understood, children, today's class, and we'll meet in the next session. Thank you, one and all. Take care.